Okay, so there is we'll do two examples for comparison test. So first is series. First series we have 1 divided by 1 dot 2 dot 3 plus 3 dot 3 divided by 2 dot 3 dot 4 plus 5 divided by 3 dot 4 dot 5. So as we know in series, first we need to find the nth term so that we can apply test according to that nth term. Now our nth term is this 2n minus 1 divided by n plus 1 n plus 2. See, this is our nth term, so you can check also that whichever nth term you have, it is correct or not. So I have checked that for n is equal to 1 I am getting the first term, for n is equal to 2 I am getting the second term, and for so on. So from that I can say that our series is, our nth term is, or the nth term I have chosen is correct. So if you simplify this nth term, then after simplification you will get 2 minus 1 by n divided by n square, 1 plus 1 by n, 1 plus 2 by n. Now if you comparison test, we need auxiliary series also. So auxiliary series we have one Vn is equal to 1 by n square. There is also method for finding the auxiliary series, that is if you divide the power of n in denominator, power of n in denominator minus power of n in numerator. This is a shortcut method to find the Vn. So if you do that, then this power of n is 2 and in the numerator you have 0, so 2 minus 1 is 2. So Vn is equal to 1 by n square. It applies in most of the questions. So if you find the ratio of un by Vn, then it will come out this: 2 minus 1 by n divided by 1 plus 1 by n, 1 plus 2 by n. So according to your comparison test, we need to find its limit. So if you find the limit of n tends to infinity un by Vn, then you will get 2. That is basically finite and non-zero term. So it means that we can apply the comparison test that this both series will behave alike. So we know the behavior of Vn because we have chosen it that manner. So un will converge if p is equal to 2 greater than 1. Therefore p series, from p series we can say that it will converge, because from p series, for p greater than 1 convergent, and for p less than equal to 1 the series is divergent. So from that we can say that Vn is a convergent series. Now its both series will behave alike, so from that, by using the comparison test, we can imply that the given series is convergent. Okay, this is done. Now we'll take second example, a little bit different from that. So the second example is 1 by root 1 plus root 2 plus 1 by root 2 plus root 3 plus 1 by root 3 plus root 4 plus dot. Now first we have to choose the un. If you choose the un, it is easy to see 1 by root n plus root n plus 1. So if you take root n common, then it will be this. And if we apply the same thing that we applied in the last question, that power in the power of n in the denominator minus power of n in numerator. So if you do that, then it will be 1 by 2 minus 0. So Vn, we can take Vn is equal to 1 by root n. If you find out the ratio, then ratio will be 1 by divided by 1 plus root 1 plus 1 by n. And if you apply the according to comparison, we need to find the limit of the ratio, limit n tends to infinity of the ratio un by Vn. So if you do that, then after applying limit n tends to infinity on un by Vn, the answer will be 1, and that is non-zero and finite. So according to comparison test, these both series will behave alike. As we know the behavior of the Vn is 1 by root n, and as p is less than 1, is equal to half less than 1, it will diverge. So it means that Pn Vn is a divergent series, and from that we can imply that the Un will also be the divergent series. That's all. These are two examples for series. One is divergent and one is convergent. So thank you for watching.